Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello, and welcome to this very special episode of the Trend Detection Podcast. I'm here today in person, not behind a screen, with my colleague, James Loach, Head of Research for Senseye. And we've got an interesting topic today, probably a bit more sort of technical than what we're used to talking about, but it's really fascinating. It's really big advancements we're going to talk about in time series forecasting, Gen AI. So yeah, it's going to be a really interesting conversation, which I'm really looking forward to. But I guess, James, welcome first of all. Welcome back. I know you've been on the podcast a few times before.
Yeah, very happy to be here.
Fantastic. And so I guess just to start with, maybe we could just remind the audience of your role at Senseye within Siemens.
Okay, so as you said, I am head of research at Senseye and have been since the early days of the company. And so during that period, responsible for development of all of the analytics, the algorithms, and the sort of related or algorithms-related functionality in the product. Okay.
Excellent. And I guess for those, I mean, maybe I'm asking for myself more than anything, but if we start very basic stuff, so time series forecasting, what does that actually mean in practice? What we talk about here? Okay,
so I mean, it can mean various different things in the end, right? But fundamentally, just taking sensor time series data recorded, from assets that we monitor, and taking some data and running an algorithm on it to predict how that data is likely to change in future. Okay, and you can end up using that for a variety of different things. So, firstly, you actually take advantage of the forecast itself to compare it to some knowledge you have about potential failure states of the machine or values that time series should not have. And you can tell the user when you're likely to enter these problematic states at some point in future. Okay, so that's sort of the most straightforward and obvious use of it in the product. But forecasting is used implicitly elsewhere as well. So, for example, in anomaly detection. So when you're detecting anomaly, you're saying there's something that you weren't expecting in that time series. For you to be able to say you weren't expecting it, you need to know what you expected. And what you expected is what you forecast at some point in the past. Okay. Yeah. So those would be the two main uses.
I'll give you a very broad question there without you knowing, but that's all right. We've opened up the conversation. So, and I guess really at the forefront of our conversation today is around, termed chronicle. So maybe you could start by explaining exactly what chronicle represents in the context of sort of time series forecasting, just sort of set the scene a little bit.
Yeah, sure. Okay, so chronicle is a machine learning model for forecasting time series and doing that in the way that I just said. It's something that can take some existing data recorded from a sensor and project that forward in time, and do so, very nicely, very elegantly, picking up on all the dynamics and interesting behavior in the training data to give you a very accurate forecast of how things are likely to develop in future. Okay. And I guess there's two things that I would say about it. I guess there's the two things that sort of motivate this conversation. I mean, one is that it's very good. Okay. So Senseye already has a forecasting system. Chronicle produces, much nicer, much more elegant, more accurate results. And then the other aspect of it is the kind of technology that it uses. So Chronicle is it's called a time series foundation model, or a TSFM, and those models use the same technology that underlies language models, which are used in ChatGPT and all these other things that we're familiar with.
And in terms of sort of development of these models, because I wouldn't know this, but how long does it actually in practice, how much work and effort and time goes into sort of developing sort of the models we're talking about, like Chronicle?
Yeah, so the amount of time you put into these things, of course, it depends on how much exactly you're doing, at what level, how deep you're starting. But to give you an idea, I mean, the history of Chronicle is that very early on in the days after the ChatGPT arrived and disturbed everybody's worldviews, we understood, like many other people, that there was this analogy between what language models are doing and what we would want for a time series forecasting system. So language model fundamentally is forecasting text. What you put in as a prompt, this is the beginning, and the language model is extending that text. Okay. And in something like ChatGPT, that simple forecasting of text is wrapped up in a conversation. So you are typing something and the language model is predicting what an assistant would say in response to your question and sort of continuing the stream. But anyway, a language model is, you have little pieces of text. You're looking at what you've got, and then you're predicting what the most likely, continuation of that is. And of course, when you're doing time series forecasting, it's the same kind of thing. Yeah, you have lots of data points. You have a sequence of these, and you want to predict the ones that follow. But anyway, so straight after ChatGPT, we understood that there was something there, and the same technology that gave that amazing performance, which is transformer models, that it may be possible to apply that to time series and get similarly big improvements in forecasting capabilities. Okay, so that is now 2 years ago, and during that period, we have been spending our time testing models that other people have created, either commercial things or open source things, and evaluating how well they work. With our data, we've been fine-tuning other people's models, so taking open source things and adapting them to our data. And we've also been building models completely from scratch, right? So from understanding the needs of our product, coming up with our own architectures and trying to train our own models. But there's a whole bunch of this stuff which has been going on over that time, right? And Chronicle came out only really of the final stage of that. So, maybe the last 3 to 6 months. And it came from us finding a model architecture that worked for us, understanding how to adapt it for our use case, making lots of intelligent fine-tuning training data and going through this process, right? So sorry, it's a very long answer, but Chronicle has not taken a huge amount of time to produce, but it sits within a very long effort, exploring this field and different approaches.
So you were just explaining then about, the efforts of you and your team, and it's not a one-time thing, it's continuous and it's still going on and you're constantly sort of innovating. But what are some of the challenges you face, during that period as you develop new models or build on existing models? What sort of things you have to face?
Okay, so there are a few things. One is that we're looking for systems that deal with the kind of data that we have, which is conditioning monitoring data. And that tends to be very different in form and structure than like stock time series data or weather time series or things like that. Okay, so looking for a model that can deal with that kind of data. We also have particular needs in terms of output. So a lot of time series models of all different types, foundation models as well as traditional things, are giving you, what we would call a point forecast. So saying this is the most probable way in which your time series will develop in future. And that is fine and sort of useful in a certain way, but, the future is uncertain, right? You don't just want the most probable route into the future, you want a distribution, okay? So we're looking to build models that produce what we would call probabilistic output. So they're giving you directly or give you the ability to produce this sort of ensemble of forecasts. So it's sketching out the future. And then the final thing is, we're a small research group. Okay, we have some resources, but not infinite resources, not the resources of OpenAI, for example. And so, we're looking for practical architectures or practical ways of doing things. So this is in terms of training things. So, we're looking to build sort of light efficient models that we can train. And then also applies to the other end as well when you're actually generating forecasts. We don't want these to be too expensive, right? So that it's practical in the product. So, practical training process and then, affordable inference or sensible inference speeds. Yeah.
So you mentioned that you and your team, you're involved in lots of different projects, but you also have to focus your time. So I sort of wondered why this particular area? What led you to sort of focus on this in particular?
Okay, so obviously, I think in general we're looking for things where we can have the highest impact for the smallest resource expenditure. Okay, and if I look at the work we've been doing over the last 2 years, the main focus of it has been in doing what maybe I could call traditional generative AI things now. So like our Copilot and using language models to generate fixed messaging, help users understand what's going on, all that kind of thing. As soon as that technology became available, this is absolutely obvious, right? That this changes the world, right? Enables us to do all of these things. So we go and do that, right? So that's been a good chunk of our work. And then this secondary thing, right? I mean, it's secondary to that. But the way I'd introduce this is to say that, we have a forecasting system already, and it is pretty good. So it's a statistical system. We have been developing over many years and continually refining, and it works better than any other system that we've been able to find or compare it to, or what have you. Okay, so I would regard this for our application as state of the art or close to state of the art. Okay, but what state of the art means here is nowhere near perfection, right? And we've often thought, when you look at a time series and you want to forecast it, I mean, humans are very good at this, right? You draw on with your pen where you think it will go, right? And can do that mostly using information which is in that time series. Okay, so you're not using lots of external information. You've got a thing, you just sort of continue it. And I would say in general that, I don't know, a 10-year-old's ability to forecast a time series with a pen would be similar to state of the art of statistical models, right? Okay, for general purpose applications sort of ours. Okay, anyway, so, there's a lot of room there to improve the quality of forecasts. And then you have this technology which has just appeared. So language models, believe it or not, have been around for a huge length of time. Okay, taking a sequence of words and predicting how they go forward. And people have made gradual progress with this. And then suddenly this technology has come along, it's been scaled, and the performance goes like crazy. Like I said, there's just a basic analogy there between time series. So you see that there's an opportunity to take this thing, which is quite core to our app, is good, but could be way better. You've got a technology there. So it feels, we should be exploring this at some level. And I'd expect many people dealing with time series are aware of this analogy and would be exploring similar things. Yeah.
Yeah. Absolutely. Okay. And because you mentioned Gen AI, and that was really the start of this journey, and the maintenance co-pilot, the start was, as part of that as well. But how do those two things we talked about link together? How do they link together?
I think they primarily, or at the moment, they would just link together via the underlying technology.
Yeah.
Okay. So same technology, different kind of information, and different output. Right. So that I guess that's the first thing to say. A second thing to say, they would link in practice in the product, right? Because what our main case co-pilot is doing is at a particular point in time, it's trying to explain why the system has generated an alert. So there's things going on in the data, there's similar things we've seen in the past, there's stuff in the documents, whatever, bringing all this information together and laying out what the possible causes might be. And forecasts are some component of that, right? So if our forecasting system indicates or says, you told me that this motor is rated at 10 amps, and I think using this new Chronicle model, right, that there's this elevated chance you're going to hit that threshold within 10 days. Mm-hmm. That information is codified and it's passed to the co-pilot, and the co-pilot would use that, right? So the co-pilot will look at the data and see there's a trend being marked. It can see, there's a forecast and it has this consequence for this reason. It can also get bits from the manual that might relate to the consequences of high current in your motor, right, for example. And it's just part of the information which is brought together and then laid out. And then one final thing to say here is I think there's not much that we're doing in all of our pipelines. Like Senseye is a complicated, sophisticated thing underneath the Gen AI. But if I look at all of those things that are happening there, I think you have the potential for Gen AI technologies to essentially, we would say, eat all of those things eventually. Right. So all of the time series type stuff that we do, I think at some point could be done by time series foundation models of different types, different styles, or trained in different ways. Okay. And then if all of your baseline analysis is handled using these kind of models, that's all Gen AI, and then this stuff is passed up to the explanatory thing, And that's just an interesting theme that I think would be playing out in lots of people's products and lots of applications.
Yeah.
At present, time series foundation models are this up and coming thing as described, right? We do certain things that would be too expensive at the moment to imagine doing with these kind of models, but you can imagine cost dropping and capabilities increasing.
Yeah.
And then things gradually being, consumed by this stuff.
Yeah. It's like 20 years ago, could we imagine where we are today? I know you said actually interesting things like Gen AI not Gen AI, language models, sorry, isn't a new phenomenon, but could we imagine where we are today, from all the way back then, the development?
No, indeed not, right. And generative AI stuff. I mean, the amazing thing there is just the curve in ability, right?
Yes. Yeah.
Once this technology scales, right? As we all know, these models acquired abilities that people did not really expect. Yeah, and it maybe an interesting thing to say is that with language models, that does open up a whole world of things. You to build agents and do all of this kind of stuff, right? So you won't expect that kind of breadth of capability out of pure time series models, because it's fundamentally just dealing with time series, right? But yeah, what one might imagine in future, combining these two different modalities and things in various interesting ways. Anyway,
we'll come back to this conversation in a few years' time, and we'll look back and see. But what I also wanted to focus on, and it's interesting you describing the link between the time series forecasting and the Copilot. But I guess the next question as well is around the impact on customers, day-to-day Senseye users and customers. What sort of tangible impact will they see, day-to-day with this technology?
Yeah, I mean, so this is an interesting thing. So our Copilot, there's a very new thing in the product. This is something that inserted that just wasn't there before. And even for the messaging that helps explain our alerts and what's going on to users. In the past, we had, a much less sophisticated, more canned kind of things. And that's just been replaced with, more sophisticated text, right? Okay. But both of those things are in quite an obvious way, I think improvements such as Chronicle, they do happen more under the hood. Okay. It's a supporting thing in there. And like I said, we already do have a time series forecasting system that performs at a certain level. Okay. But what users would actually see with this, right, is essentially they would just see much higher quality forecasts. Okay. So forecasting in our product is used quite widely. It's a very useful feature. The forecasts that the system generates are shown in the product. Users can see them and judge whether they like them or not, or the quality and so forth. They will just improve, right? So users will see, they just look more sophisticated. Yeah, these models have the ability to pick up on complex dynamics that the current model just does not have the flexibility to do. And in practical terms, what that means is that our forecasting system will be more trustable, right? It will produce better forecasts and more accurate predictions of when assets are likely to enter failure states and all of this kind of thing. So we'll take a bit of our app, which is useful, and make it hopefully a good deal better, improve the quality of our alerts, all of these sort of things. And then down the line, as we sort of touched on, you can imagine using these models in a similar way for all of these other basic bits of analytics that support alert creation. But this is not adding new things to our system at the moment. It's just superpowering or tuning up,
enhancing what's already there. Yeah. And I guess so. In terms of a sort of release date for this, I don't know if you want to commit to an exact date on this particular podcast, but it's coming soon, right? And in terms of sort of successor models, and obviously, like we said before, you and the team are continuously sort of reviewing this and looking at improvements like you do. But is there a roadmap? Anything you can reveal around that, around what's sort of coming next, or?
Yeah, I mean, so we've been in a research phase for this particular bit of functionality, like I said, for a few months. the engineering on this to put it in the product starts the Monday after when we're recording this, right? So middle of January 2025. And in terms of rollout to customers, I can imagine this happening in a couple of months from now. But it just depends how we decide to stage that.
We're not committed to anything. But
it's not a research topic; it's now a product.
Of course,
it's a thing. And then I think as a research group, we would just continue this thread, exploring what else we can do with these models, keep up with the latest research. So the other things that we might do with this, I think. Turning our attention to anomaly detection would be one thing. Okay, we do a lot more anomaly detection in Senseye than we do forecasting. So with anomaly detection, there is more of a concern over the cost of running these models and things like this. So we might be building some lighter, faster version to use for anomaly detection. And then the other thing I mentioned. This is something with language models which sits under the hood in many products, such as ours, which is something called embeddings. So you can extract vectors of numbers from language models, which capture the meaning of the text which is sent into them. Okay. And this is, it's sort of intrinsic to how they operate, but it's also a nice side effect that allows you to do this. And so what you can use those embeddings for is to take bits of text and identify whether they're semantically similar to one another. Mm. Okay. And so in Senseye's many similar apps doing this kind of thing, you use those embeddings to find bits of documents that are relevant to a question that somebody asks. This is called a RAG paradigm, right? you do this thing. But anyway, language models give you these embeddings that let you judge the similarity of bits of text. And that turns out to be quite useful. And it may turn out that the equivalent of those embeddings for time series also turns out to be useful in a similar way in telling you that bits of time series are similar to one another in a meaningful and useful way, right? And hopefully a way which, you might use to predict the occurrence of failures, right? Or just to identify similar things that happened in the past so you can sort of contextualize what's going on. There's a whole massive stuff, right?
Yeah. Almost a separate podcast could be about that, right? So,
at some point maybe.
But I think the important thing to note as well is there's always a focus on the end customer. What's the improvement to the end customer? That's what I always like about, the product team at Senseye. And it's talking to customers, understanding where, and I guess you're part of that conversation as well.
So I think Senseye is quite good in this way, right? We are looking for general opportunities, of course, but, we're fundamentally driven by customer need, things that people want, see a lack of in their current systems and what have you, and filling those gaps.
So we're coming towards the end of our chat, James, but I wanted to finish on, I guess, more of a sort of personal note as well, because there's been a lot, I've been at Senseye now, Siemens, for 3.5 years. There's been so much change in that period, and you've obviously been, as you said before, and with Senseye now, Siemens, a lot longer. But how excited are you at the moment, or how much excitement do you have for developing all of this stuff and looking into the future and what's coming next, just to get sort of your feeling on that?
Yeah, no.
It's a great place to be, isn't it, really?
Yeah, sure. It's obviously an exciting time. And personally speaking, there are two periods for Senseye. One is the before Siemens days, which also coincided with before generative AI days, right? Okay. And joining Siemens has coincided with this whole new stack of technologies that we didn't have before, right? So obviously that keeps things interesting, right? And then, so generative AI so far has not turned into a thing that is starts full of hype and then everybody becomes disappointed and disillusioned and goes back to what they were doing before or what have you. It's still just progressing extremely fast and extremely strongly, right? and probably I said this on the last podcast as well, to a scary extent, I would say,
Yeah, because it's not even within our world, let's say industrial world, but also in just everyday life, right? So it's not, there's some, incredible use cases coming out just in our everyday life. I mean, I was listening to a podcast from the Microsoft CEO the other day. He was just explaining how, you'd be booking holidays via sort of co-pilots and things like that in the future, rather than visiting websites. It's really amazing how far this technology can go.
Yeah, it would just be interesting to see quite how far it can go.
Yeah.
A long way, certainly, and maybe it does indeed go all the way, right, in the end. But it's just the technology of our time. And it's obviously fun to be using it every day and developing it. Yeah,
exactly.
To the extent that we do. Yeah.
Yeah, and we'll see where that takes us. Just the start, I'd say. But yes, that brings us to the end. Thank you, James, for sort of showing your expertise and knowledge. And I mean, we'll look forward to seeing how this, well, I say it's just a starting point. Well, it's just not even a starting point. It's a continuation, isn't it, as we said. So there's a lot more to come. But yeah, for today, thank you, everyone, for listening and watching. And we'll see you on the next episode.
Make sure you like and subscribe on all major podcast channels. And to find out more about Senseye Predictive Maintenance, go to Siemens.com.